My name is Angelo Gutierrez. I'm doing this project for Introduction to Chemistry for my amazing professor, Professor Turner. Now, my specific section will be solutions. Now, what is a solution? It's a mixture of one or more solutes dissolved in a solvent. Now, a solute is the substance being dissolved. Typically, it will be the lesser amount. For example, it will be sugar. And now for a solvent, it will be the substance that dissolves the solute, typically the greater amount. So water and sugar, water will be the solvent and sugar will be the solute. Now for some specific general rules for solubility. Like dissolves like, meaning a polar substance will dissolve a polar substance and a non-polar substance will dissolve a non-polar substance. Before I conduct a experiment designed for polar substances dissolving polar substances and non-polar substances dissolving non-polar substances, I will go over what a polar molecule is. It's basically where there is an excessive amount of electrons on either the positive or negative side of the molecule. And then a non-polar molecule is one where the electrons are distributed more symmetrically and thus not have an abundance of charges at the opposite sides, meaning charges cancel each other out. Before I conduct an experiment, safety is always first. For this experiment, I will be mixing basically a polar substance, which is water, and a non-polar substance, which is extra virgin oil. Now, I'll be dropping about 3/4 of a cup of water. And then I'll be dropping, I don't know how much extra virgin oil, but as you can see, they don't mix because the water is polar and oil is non-polar. I can stir it and they still won't mix. Now, how do we get rid of this oil since it's non-polar and I can't really clean it up with water since it's polar? Basic solution for that is dishwashing soap. Dishwashing soap is actually non-polar and it's designed to go ahead to get rid of oil. Now let's go ahead and mix them together. Non-polar with non-polar. Quite a bit of a dishwashing soap. And let's mix it together. I should have grabbed the spoon. As you can see, non-polar with the non-polar, extra virgin oil with dishwashing soap, basically cleaned it all up. It mixed together and got rid of each other, leaving my water left. Kind of. That's just the food coloring from the dishwashing soap. Now, we all had the question about what happens if you raise the temperature of a solution. Well, if you increase temperature, solubility will increase. Well, everyone has that question as well as, what happens if you increase pressure? Well, you increase pressure, you increase solubility. Now, let's get to a topic about saturation in solubility. Now, what if I had this amazing beaker with, let's say, 100 mils of water, and I add these little dots that are sugar into the water. Now, I can only put about 77, and then no more will go ahead and dissolve in the water. If I go ahead and do less than 77 grams of sugar in the water, then it's going to be unsaturated, meaning there'll be less than 77 grams of sugar in here. Now, what happens if I applied all 77 into the solution? Then it'll be saturated. And then what happens if I add a little bit more? If I increase the temperature of this, making it have intake a little bit, making it sugar dissolve a little bit more, then it'll be super saturated because more than 77 grams of sugar is being dissolved. Now, rate of dissolving. Now, how exactly will something dissolve quick? Well, the particle size matters. If I try to dissolve, let's say, this huge piece of sugar in water, it's going to take quite an awful long time. If I were to crush this thing, which I'm not going to do, into several little pieces, then it'll dissolve a lot quicker because of the surface area. Now, the concentration of the solution also matters, and as well as stirring the solution. If I were to stir my solution multiple times, then it'll dissolve pretty quick. Now, what about the solution concentration? We need to keep in mind the dilute solution as well as the concentrated solution. Three important formulas that we learned in this chapter are concentration, which will be amount of solute divided by solution, mass percentage, mass of solute divided by mass of solution times 100, and molarity, moles of solute divided by liters of solution. I'll give some examples in a little minute. Here's a question involving molarity. What is the molarity of a solution made by dissolving 2.355 grams of sulfuric acid, which is H2SO4, in water and diluting to find a volume of 50 mLs? First, we have our constant is going to be 2.355 grams of sulfuric acid. So let's begin with that. We got to change that into moles. So we'll find the molar mass of sulfuric acid, which will be 98.08 grams. And on top will be moles, and that would equal to about 0.024 moles. Next, we just used a simple formula. We put moles on top. Now this one's in millimeters in the beginning, so we need to go ahead and make that into liters, which will give you 0.050 liters. Go ahead and put that into your calculator and you should get around 0.48 moles per liter, which will give you your molarity. Here's the next question. Hydrochloric acid is sold commercially as a 12.0 moles per liter molarity solution. How many moles of hydrochloric acid are in 300 mL of solution? Now, first things first, this is going to be a molarity problem. So, we already set up the equation, so they give you the molarity, which will be 12. Now, we have to find numbers of moles and numbers of liters, but they already give you the volume, which is going to be in milliliters, so you're going to have to convert that into liters, which will be 0.3 liters. Next up, we're just going to have to multiply the denominator with 12, and it should give you 0.36 moles.